So let's talk about one of our closest galactic neighbors, the Triangulum galaxy. For, well, basically centuries, we thought we had it all figured out. But it turns out, this galaxy has been hiding a massive secret right in plain sight. Uncovering it is honestly a fantastic cosmic detective story. Okay, let's get in.
All right, so this is Messier 33, or M33, the galaxy in question. And when you first look at it, yeah, it's a spiral galaxy, but it's kind of fluffy, right? The arms aren't these big, bold, perfectly defined spirals. Astronomers have a great word for this: flocculent. It's really just a fancy way of saying it looks patchy and a little chaotic. And for the longest time, that's what we all thought it was. Just a simple, beautiful, but kind of messy galaxy.
But what if that whole chaotic look is just a disguise? What if underneath that fluffy surface, there's a totally different structure, a structure that tells a much, much more dramatic story about its past? What has this galaxy been hiding from us all this time?
To crack this case, we first have to go over the evidence. The galaxy we thought we knew. Let's open up the official case file on Messier 33.
Okay, so here are the basics. M33 is just under 3 million light-years away. That makes it the third biggest galaxy in our local group, right behind Andromeda and us, the Milky Way. It's got around 40 billion stars. Now, that sounds like a ton, but it's actually only about 10% of the stars in our own galaxy. And based on that fluffy look, it got classified as an S-type spiral, which totally fits with that open, unstructured appearance.
But as any good detective, or, astronomer, will tell you, you have to look closer. And when they did, some things just didn't add up. These are the unsettling clues, the little details that suggested there was way more to M33 than meets the eye.
Clue number 1, the center of the galaxy. See, most big spiral galaxies, like our other huge neighbor Andromeda, have this big, bright central bulge, this dense ball of old stars. But M33? It's pretty much all disk. It's just missing that big bulge, which is super weird for a spiral galaxy of its size.
And clue number 2 is tied right into that missing bulge. If you don't have a big center, you probably don't have a big central black hole. And M33 doesn't, but its black hole is shockingly tiny. The upper limit we've been able to measure is less than 1,500 times the mass of our Sun. In cosmic terms, that's an absolute featherweight.
Now, just to put that into perspective for you, the supermassive black hole at the heart of our own Milky Way is 4 million solar masses. M33's is practically a ghost in comparison. So the big takeaway here is M33's core is just different. It's not playing by the usual rules.
And the last big clue is out on the edges of the galaxy. The whole outer disk of M33, we're talking both stars and gas, is seriously warped. It's bent out of shape like a vinyl record you left out in the sun. And that is a classic textbook sign that this galaxy had a major gravitational run-in with something else. The mystery was definitely getting deeper.
Okay, so with all these strange clues piling up, it was time for a real investigation. To crack this case, astronomers needed to find a way to look at M33 with totally new eyes.
And they did it by looking at the galaxy in different kinds of light. What you're seeing here are 4 completely different views of the exact same galaxy. The optical view is what we see. But ultraviolet light over here, that only shows us the hot, young, blazing stars. Infrared lets us see the cooler, older stars and all the dust. And radio waves map out these enormous clouds of hydrogen gas. If you want to solve the mystery, you have to look at all the evidence, and each wavelength tells a different part of the story.
And the real key to this whole thing was to stop looking at all the stars jumbled together. Instead, they had to separate them by age into what we call stellar populations. The bright, flashy young stars, they're like the new flowers and bright green leaves in a forest. They create a lot of visual noise. But the real secret to the forest structure, the galaxy's underlying skeleton, is found by looking at the ancient old-growth trees. For M33, this meant finding a way to filter out everything except the oldest, coolest red giant stars.
And when a team of astronomers with the PHATTER survey did exactly that, using the incredible power of the Hubble Space Telescope, wow, they found something nobody was expecting. This is the big reveal.
Okay, so first, let's just confirm what we think we know. If you only look at the young, bright stars, what do you see? Well, you see exactly what we've always seen in pictures of M33.
A chaotic, flocculent mess. Yep. This picture, taken in ultraviolet light, pinpoints where all the youngest, hottest stars are. It's all these bright, splotchy patches and little broken arm segments.
This is the M33 we all thought we knew.
All right, but here it is, the moment of truth, when they filter all of that bright young chaos out and look at only the ancient red giants, the galaxy's true skeleton. A completely different picture comes into focus.
And look, this wasn't some minor correction to the textbooks. The researchers themselves said it best. They said the results represent a dramatic shift in our understanding of M33's structure. This was an absolute game changer.
And this is what they found. Hidden under all that mess from the young stars was a beautiful, orderly structure. It turns out M33 isn't a flocculent spiral at all. At its core, it's a grand design spiral with two big dominant arms. And get this, for the first time ever, they confirmed it has a central bar running through its core. That whole fluffy look, it's just a thin layer of new stars. The real M33 is a hidden, barred spiral galaxy. Mind-blowing.
So now we've got a hidden identity, and we've got clues of a violent past, like that warped disk. The last piece of the puzzle in this cosmic crime story is to figure out who or what did it. What could have possibly disturbed M33 so much?
And this is where it all clicks into place. The new data showed that the inner arms were lopsided, which you can see traced out here. And when you put that inner disturbance together with that huge warp in the outer galaxy we already knew about, you get a clear, galaxy-wide pattern of disruption. This is the smoking gun. It's the unmistakable sign of a massive gravitational tug-of-war with something else. And when you look around the neighborhood, there's really only one suspect big enough and close enough to do this kind of damage: the Andromeda galaxy. A close flyby in the past would have been more than powerful enough to bend M33's disk out of shape and trigger all the weird patterns we're seeing now. Case closed. So, we've solved the mystery of M33's secret identity. But why does this actually matter? What does it really tell us about the universe? This is the verdict.
Well, this is so important because M33 is in this really unique sweet spot in our cosmic neighborhood. For instance, the chart on the left shows it's actually forming stars at a higher rate than its huge neighbor Andromeda. And the chart on the right shows its chemical makeup puts it right in between small galaxies like the Magellanic Clouds and big ones like Andromeda. It's this perfect crucial link. So understanding its true nature helps us piece together a much better story of how all spiral galaxies, including our own, form and grow over time.
And really, this whole thing leaves us with one last kind of staggering thought. M33 is one of the closest and most studied galaxies in the entire sky. If we could be this fundamentally wrong about our own next-door neighbor for so long, just imagine what other incredible cosmic secrets are still out there, hiding in plain sight, just waiting for us to find the right way to look.